Yeah, welcome, Shylaja. Shylaja is a trained astrophysicist and working in the planetarium since some decades, half a quarter of a century now. And she's also a member of the working group Star Names, and that is why presenting of the IAU, and that is why she will present now about star names in India.
I first of all would like to thank Susanne, Doris, and others here, because this is a wonderful opportunity for me to visit this town, which has always been held in great reverie for me. Because I used the 1 meter telescope of the ZEISS for my thesis, and then subsequently the ZEISS planetarium for more than 2.5 decades. So I'm in love with this ZEISS people and the ZEISS equipment. And so it is a pleasure for me to be here, and I thank you all for giving me this opportunity. I would be talking about the uses of star names because I have already published several papers related to this, but there are several other uses of star names which sort of I feel are unusual. So I'm going to spend more time on that. I should make this full screen.
It is full screen.
Then which one should I press? Okay, then the next one. Okay. So, why do we need the names of the stars? Of course, to fix the position of the moon and the planets, this was the basic requirement. And then you can always do that with the names of the constellations. The 12 constellations would suffice for that purpose. But if you want to fix it more accurately, you would need the stars. And if you want to keep on improving the calculation of the position of the moon, you have to be very precise, and that precision can be obtained by methods like lunar occultations. And therefore, the names of the stars were very useful. And it's the same 28 star system which he spoke in the previous lecture that is very popular in India. I will tell you how popular it is even today. And the coordinates of the stars are generally mentioned in every textbook, every treatise in the context of conjunction. So first they calculate for the moon and the other planets, what's the condition. And then they replace one planet with the star and say that now the calculation has become easy, and they list the coordinates of the stars. That's why this is very important. Now, these are the 27 star systems. As you can see, the names are all, they were listed in his talk also in the bottommost row. And these are also useful for fixing the precision, because the same path is taken by the sun also. And this method has been used very successfully for dating old scriptures like the Mahabharata and Ramayana, because there it is very clearly mentioned that the year began when the first point of Aries, what we call as the first point of Aries, the intersection of the ecliptic and the equator, happened in the near the star Kritika, which is Pleiades. So using that, we can date the work of that. So similarly, this has been used for various purposes. So then the names of the months, which we use colloquially in the lunar calendar system, which is prevalent in India, are derived from the names of the stars. So a common man will today wonder what it has got to do with it. For example, there's a star called Chitra, which is Spica, Alpha Virgo, and the name of the month is Chaitra. It's related to the position of the full moon in that month. That is how it is related. And I have brought a piece of a calendar, the old calendar, which we use even today. And the calendar, there are so many things that are marked on the left-hand column. I'll circulate this, you can see that. And the names of the stars are listed there. So the name of the star I have circled as here as Jeshta, which is Antares. And that is Alpha Scorpio. So you can go to the stellarium thing and verify that on that particular day the moon was near Antares. To that accuracy, it is possible. And then you have the star name for the sun too. The position of the sun also is fixed by the same 27 stars. And then of course you have it as a time marker. So sometimes the astrologers mainly, when they refer to the word nakshatra, they don't mean the dot in the sky, but it's a time marker. So the interval taken for the moon to move from one star to the next star is divided into 4 parts. And so to that accuracy, you are able to give the time of birth. So this is what is meant by the star name in horoscopes and by the astrologers. But every one of them has a correspondence in the sky also. They are called yoga taras. Okay, that is the position where the star Jeshta is marked, and that is the picture from the stellarium that I have taken. And then star names of the sun are marked in the bottom because there are 2 positions in a month for the sun. So those 2 stars are for January. One is Sigma Sagittarius and the other is Alpha Aquila. And I have marked that here, so you can pass it down. It will be asked best to him and pass this on. So this is one use of the star names, which is in use even today. And all astronomy texts have the conjunction of the moon and the planets. And then they finding the time of the year, looking at the night sky, finding the time of the night by looking at the phase of the moon. And then, of course, fixing directions in the night, even when the pole star is not visible. And of course, there are some special navigation and special skills of the fishermen who do not read and write. They are, in that context, you can classify them as illiterates. But then they have developed their own methods for looking at the sky and identifying where to take a turn. If they are moving along the west coast, where should they take a right turn to reach a particular port? So, and then what's the time of the night? And interestingly, after the colonial period, they have started calling Canopus as the star of Jesus. Because on the Christmas night, they will see it crossing the meridian at midnight. So, Yesu Nakshatra, they call it as Yesu Nakshatra, which means the star of the Jesus. So this way, they have evolved their own methods for identifying the directions of navigation and on the sky. And so the coordinates are listed in every textbook for a specific epoch. So when they, but then you will find these names of the stars in literature as proverbs, as fiction in yesteryears, and many beautiful puzzles are all framed around the names of the stars. And it's very interesting because they have some correspondence with some object that we use daily. And then there are artworks and sculptors, and all festivals and agricultural practices are all dependent on the star names. So the illiterate farmer goes to the priest and asks him, what is the rain star this month? He gives the name as, say, Mrigashira, which is Lambda Orionis. Then he says, okay, I'll wait for 15 more days for starting my agriculture. You know, this is the way these names are all imbibed into the agriculturists. So we, now, these are all hearsays. So if we want to identify them and put them on the star chart like this, we need the coordinates. So fortunately, we found one which is dated the 14th century. It's actually a manual for using the astrolabe. So in that context, they have listed, and so we extracted the coordinates and identified so many stars. This is first half of the thing, and then the second half is here. So as you can see, there are stars along the ecliptic. There are stars beyond that also, and there are some in the north also, and some in the south, down to Centaurus, because from South India, Centaurus is visible. So the names are very not very popular other than the 27 that are used colloquially. But the names are there, the coordinates are there. Somehow they were forgotten over the last 400 years after the British system of education was introduced. And then people were exposed to European astronomy by the British, say in the 19th century. So they started coining new names of the stars, translating them from the Arabic or the European names. So today we have a mixture of both kinds of names, the original ones and the ones which are translated. So I'll give you one or two examples where the names have been forgotten. And this is from the 16th century manual. As you can see, some of the stars of some of the 27 stars are not on the ecliptic. They're slightly above or below because you will not be able to find them. The best example is Alpha Bootes. It's so far away, but it is one of these stars. Similarly, we have Lambda Orionis, and then the interval between them also is very small. So to identify them in the sky is first challenge, and then match with the time unit is another challenge, which somehow they were managing. And then we found some unusual names. For example, here is this paper is published already. We have a series of papers, me and Venkateshwara. And you see the three steps there, three double stars which are marked in the constellation of Ursa Major. It has a name called Trivikrama. It has a story associated with it. That one, when once the Lord came down to punish a demon, he came in the disguise of a young boy and said, "Give me something, I'm poor." The king said, "All right, I'll give you." He said, "I just want 3 steps and 3 steps of land." So one step he covered the entire sky. The next step he put on the entire heaven. And then the king was surprised and then said, "Where will you put the third one?" Then the third one he put it on the king's head and pushed him to the underworld. This is the story. And that's the name of Trivikrama, and they have identified that with 3 double stars. And these are something unusual. They're not commonly known. The story is known, but their association with these kinds of stars is not very well known. Cassiopeia is called as Supita. Supita means a very good chair. And the stars, Gamma Cassiopeia is called the foot of the chair, and the other is called the back of this chair, and so on. But I don't find a correspondence anywhere else. These names were forgotten. They have been forgotten. And so this book provided us these kinds of names here. And of course, this is the astrolabe, the special astrolabe, about which I have already spoken earlier. This is somewhere in Germany, in somebody's personal collection. One can look up the catalog of S.R. Sharma, and this is the first one listed in under the category of Sanskrit astrolabes. So then in the top you have 2 stars that are marked with the same pointer, and that pointer has a name Dhanu Sharagra. It's a name unusual. It's not known. It literally means the tip of the arrow in the constellation of Sagittarius. That's what it means. And the person, those days, David Pingree was very well versed with Indian astronomy. So he was asked to identify that particular star, and he associated it with Mu Sagittarius. And Mu Sagittarius is not that great a star to go into the day of astrolabe. Then I verified and found that this is dated 1604. It was prepared in the year 1604, and the position exactly matches with the supernova of 1604. So that's what the identification is. So I put the blue arrow there corresponding to this. So this way, the supernova has gone on to records, but then it could not be identified so easily because David Pingree, when he looked up the catalog, it was not listed in the catalog as a bright star. It's a forgotten star because it faded out within a year. And similarly, I have found that Beta Cassiopeia, this has come in various astrolabes. Sharma's catalog is 3,000 pages. It's available online, free downloadable. So he has cataloged all details of all astrolabes available all over the world. He has visited several museums and visited several universities and collected from personal collections and made a list. And then I found that Beta Cassiopeia is also very common, not the other stars of Cassiopeia, but Beta Cassiopeia. So whether that was a remnant of the 1572 supernova. So that part I need to analyze more carefully, because I need to collect all the information about Beta Cassiopeia and the vicinity of the 1572 supernova. So maybe that was done, because the person who prepared the astrolabe was an astronomer, all right, but then he was not aware of any event like a supernova. So he saw a bright star and he marked it on the star day. That's it. So he was not very keen on knowing whether the star continued to stay there or so. So on the day when he saw it, he has marked it. So if you go by that, then perhaps the 1572 supernova also is recorded. And then there is another interesting thing that I find in these catalogs, that is, instead of giving the names of the constellations, they divide the entire globe into sectors of 30 degrees, and they call it as Aries. They simply call it as Aries. Aries means 0 to 30 degrees. The declination can be anything. So everything in that belt will be called as under the constellation of Aries. And this I found, and then I was able to trace a particular episode recorded in a stone inscription in Thailand, Cambodia, and could perhaps identify it with the pre-flare of one of the planetary events, planetary nebula events. So such a thing is possible with these kinds of records. And then we have history and mythology here. Now, the star Lambda Orionis is listed as a bright star, one of the 27 stars. It's called as Mrugashira. Mruga means it's a deer. Shira means the head, so it's the head of the deer. Why that particular faint star was chosen? It's not visible to the naked eye at all. You have to make an effort to see that. And then there is a story associated with it. Brahma, the god of creation, had 5 heads. And the 5th one was chopped off as a punishment. Okay, the punishment part is another story. Then at that time, he had assumed the form of a deer. So it is called Mrugashira, and the part which is chopped off. Now, is it a remnant of some event that we saw in the sky? It will remain a speculation, because I have no means of proving it. And then this name is not common with any other culture. This Mrugashira name is not common with any other culture. And I had gone to Leiden for a conference, and there I found a discussion on this Lambda Orionis. And there is a super bubble there surrounding Lambda Orionis. And the discussion was on the estimation of the distances. It ranges from 518 light years to 1434 light years, a very large range. So if you put it in one specific range, it's possible that several 100 years ago there was a supernova event there, which was remembered, and then people saw that the star was fading away, and so they rigged up a story that the head was chopped off. So that's possible. So these kinds of things will remain a speculation unless we are able to prove. Then this is another interesting thing of the application of the star names. This is a text where in that table, the table that you see are all the names of the stars, and below that there are some numbers. So then we try to understand what is this done, and the numbers are all there in the textual form also, and then the person who rewrote the text, made a copy of it, has prepared the table. So what is this table? This is the table. So here are the 27 stars. And then look at the numbers. Ashwini is the first one. And it should have started with a 0 or 1 or 2, but it starts with 104. And the next one is 114, and so on. Ashwini, Bharani, Kritika, and so on. These are the names of the stars. So you can very easily see that there is an offset of 90 degrees approximately. And then we worked on the ascendant part, which I was discussing with you yesterday. And it works out beautifully as the ascendant. When this particular star Ashwini, which is Beta Aries, which is on the meridian, when Beta Aries is on the meridian, what is on the eastern horizon, which longitude is on the western horizon, eastern horizon, that is 104. Similarly, Bharani has 41 Aries. When 41 Aries is on the meridian, which longitude is on the eastern horizon. So this is the thing that has been listed. And this was very important because for all festivities and celebrations, the time should be mentioned. What time are you going to celebrate it? And the time is given in terms of this ascendant, that is the point on the ecliptic, which is on the eastern horizon, even today. Even today, all religious functions, you will find that the time of the ascendant is mentioned. And so this was very important, and they had to memorize it. And therefore, this whole thing was coined into a phrase, and they would memorize it. And this work, and this is where I felt the need of the stellarium, as I mentioned yesterday. So here, this is the dot in the sky is called a Yogatara, because nakshatra means both the time interval. It also means the dot in the sky. So to do that, so we have this listed. We calculated the whole thing, and the point is that the longitude corresponding to Ashwini may be on the meridian, but star itself may not be, because the star has a finite latitude. So it takes a while for it to come to the meridian. That small correction has been taken care of. So this is very interesting. So this part is we are working on this. And so this is the concept of Lagna, which is the ascendant. So you have this point or this point, we need the longitude of this point here. Okay, so which varies throughout the year and is a strong function of the latitude of the place. And then there is an instrument in the 8th century text and another in the 12th century text. How do you find the ascendant? They have a special instrument to use this. You have to look at the horizon and mark this. It's very easy to do it in the night. And in the daytime, you have to use the position of the sun and extrapolate it to get this. So the description of the instrument is also available. This sounds very elaborate, but it's a very small device with a board and a sighting tube, that's it. Okay, so this is the formula that you need to use. So that correction you have to apply, and then this correction you have to apply, provided the star is on the ecliptic. But if it is away from the ecliptic, then you have to apply yet another correction. So that correction also has been taken care of in the preparation of the table. As you can guess, this is a very tedious calculation. So this is the simplest way I could do with different colors. When Ashwini is on the meridian, what is on the horizon, etc. This I tried, but the figure becomes very complicated as I do it for more number of stars. So if I could simulate this with stellarium, it would have been wonderful. And if the stellarium provides me the ecliptic with graduations, then I will be able to pinpoint and say, look, this is the number that's in the table. And that was 17th century text, and from Banaras, Varanasi. And this is from a different text, which is this person, Dikshit. He was the first one to write the history of Indian astronomy. And he met a person who was able to recite this And then he would say that if this star is on the meridian, he would recite a poem and say, according to this poem, this is the ascendant. And then the numbers are all coded like this: cow, hu, ja, three, gu, and so on. These are all coded numbers, and he would decode them and say, this is the longitude of the ascendant. And this is from a location near Kolaba in Mumbai. So these numbers are obviously different from the list I had shown earlier, because this is for a different latitude. So such tables were prepared, memorized for specific locations. So each astronomer, local astronomer, his job was to do this, I think. And so you are likely to find many more such verses. And so here I have three things. One is from Varanasi, the other is the one I mentioned just now. And I found another one here, the third one. This was published a few months ago. And this Professor Krishnamurti, he was a professor of engineering in one of the technological institutes in India. After his retirement, he took to writing books of various topics. He sent me his copy a few months ago and requested me to go through it. It was the same thing, what I described now, he had written as a book. He is 97-year old. And when I told him I need some more time, he said, how long do you want me to wait? I'm already 97, he said. And he said he has typed the entire book, which is one finger. So I gave him my comments, and I think the book is now published. It's available on the Amazon. And as a small boy, he was being taken to the riverside by his father at the early hours of morning, and that place is down here in Tamil Nadu. So he would recite that verse, show him this particular star is here, and therefore this is the ascendant, and today the sun is here. So how much of time is left for the sunrise? Calculate orally. So this boy was trained for that as an 8-year-old, and he remembered it now. He has put the entire text in that book from his memory. And so that's a wonderful thing, I thought, and so I have included that here. So this latitude is approximately 11.8. So now I'm only discovering new things of the application of the I've already found for 3 latitudes. I'm likely to find it if I put my hands and search thoroughly at other latitudes also, because I have to take a careful look at the list of stars that have been provided. So this is, I thought, an unusual application of the names of the stars and the way it is used for finding the time of the night. So the procedure for calculating this is very tedious. So as you mentioned, we have to write a program for this. I have to calculate from alpha to delta, delta to correction, and then correction for the latitude, and then go back to lambda again and find out what's the value of lambda. It's a very tedious process, and it's quite elaborate. So I request Stellarium to provide me an ecliptic with a grid so that I can simply read it out, setting the declination and the time of the meridian passage. So Stellarium is very badly needed. That's my art here. So thank you for the patient listening. So if there are questions.